All right, everybody, welcome to the video here for lesson number 9 or lesson number 8, depending on which class you're in, on seeing structure and factoring by grouping. So the first question here has us factor by grouping. So I'm going to start by making my little dotted line down. I'm going to take out x squared, leaving me with x minus 6. For the next two terms, I have a common factor of 25. Notice the signs are opposite. One's positive, one's negative. For the other side, I see that the GCF is 25 here, and I'm going to take negative 25 out. This way I get x minus 6, so they match. Right, remember, we want these two terms to match. Since they match, my two factors are x minus 6 and x squared minus 25. Ask that question I keep asking in class, can I still factor? And the answer is yes. So I can factor x minus 6, x minus 5, and x plus 5. For the next one, we have 3x cubed minus 5x squared. GCF is x squared, so I'm left with 3x minus 5. For the next one, GCF is negative 16. I want to take out the negative so that my signs match up. Factor 3x minus 5, x squared minus 16. Can I still factor? Yes. The x squared minus 16 can factor to x plus 4, x minus 4. Number 2 says determine if the expression can be factored with real coefficients. If so, factor the expression. So if we can factor it, that means they're going to have a common or like term. So I have 2x squared is my GCF, leaving me with 2x plus 1. Here I have negative 18, leaving me with 2x plus 1. So that means this can be factored. We actually did this one in class. So we have 2x squared minus 18, 2x plus 1, take out a 2, x squared minus 9. Again, always looking for that GCF. That's the one everybody forgets. And then difference of two squares gets us to our final factorization. For the next one, the GCF of the first two terms is x squared, giving us x plus 3. GCF of the last two terms is negative 1, giving us, or not negative 1, negative 2, giving us a x minus 3. These are not the same, so this is not factorable like the one that we had in class. Number 3, if we do some distributing, that would work, but instead, I see like terms. So I can factor this to x plus 4 and 3x minus 1. Now, if you distributed it, you're just going to get a trinomial that you can factor using the AC method like we did in the previous lesson. And it totally would still work. It's just a lot more work. If you see the structure, it makes it way easier. Number 4, let's look for our GCF. We have an x cubed minus 4x squared plus 4x minus 16. If you didn't notice that GCF and you did grouping right away, it still works. If I do some grouping here, I have x squared, x minus 4, 4, x minus 4. So my final answer is going to be x squared minus plus 4, and x minus 4. Nothing left is factorable. Number 5, consider the expression. Explain how you can use grouping to factor this completely and then factor it completely. So you can group these into 3 separate groups. So I'm going to group it into 3 groups of 2. So I can use grouping here because I can find common terms. I don't want to combine like terms here, right? Combining like terms here will actually make this more challenging. So if we do grouping, we have x squared, leaving me with x minus 3. We have negative 6x, leaving me again with x minus 3, so we have a like term. We have positive 8, again leaving me with x minus 3. So my two factors are going to be x squared minus 6x plus 8 and x minus 3. Can I still factor? Well, it multiplies to make 8, but adds to make negative 6. I don't have to do the breaking apart of the middle term here because the coefficient on x squared is 1. So I can just rewrite this as x minus 2, x minus 4, because that multiplies to make 8, that adds to make negative 6, and x minus 3. Next expression, how can we group these? I would group these into two groups of 3. That's my explanation. Factor out your GCF, x to the 4th, leaving me with 2x to the 2nd minus 7x minus 15, and a negative 1, giving me a 2x to the 2nd minus 7x minus 15. Like terms, so I have that x to the 4th minus 1, which is still factorable. I have 2x squared minus 7x minus 15. First one, if I factor, becomes x squared plus 1, x squared minus 1. This one I'm going to have to do my break apart thing. So I have multiplied to make negative 30, but add to make negative 7. So that's going to be negative 10 and 3. So I'm going to make this 2x squared minus 10x plus 3x minus 15. Do my grouping here, 2x, leaving me with x minus 5, 3, leaving me with x minus 5. So then I'm going to get factors of x squared plus 1, that can't be changed, x plus 1, x minus 1, because I can factor that expression, 2x plus 3, and x minus 5. Look at all those factors. Number 7 says solve using the quadratic formula. Subtract 9 to both sides, so I have y squared minus 3y minus 9 equals 0. Quadratic formula we know because we did this in Algebra 1. If you don't, well, guess what? We're going to do it again in Algebra 2. So if you remember from this, we have A, B, and C terms. So the A term is 1, the B term is 3, and the C term is 9. So if I plug into my formula, I get x equals the opposite of negative 3, so positive 3, plus or minus the square root of 3 squared minus 4 times 1 times negative 9. And that's all divided by 2 times 1, which is just 2. Figure out what we got underneath the radical, so I have x equals 3 plus or minus the square root of 45 over 2. And we're going to simplify the radical. I know we didn't really do too much of this in 9th grade math, but it is something we did in geometry. So I have 3 plus or minus 3 square roots of 5 over 2. Honestly, I'm happy if you got this far. Number 8 says to factor completely. I see some like terms, x to the 2nd, which is going to leave me with 4, y to the 4th, minus 25, x to the 2nd, z to the 6th. Then I have to ask myself, can I still factor? The answer is yes. I see difference of 2 squares here. I see subtraction, perfect squares, all that stuff is there. So the x squared just hangs out front. I have 2y squared minus 5x z to the 3rd. And I have 2y squared plus 5x z to the 3rd. Nothing else can be factored there, so we're done. 1 plus x to the 9th power. This is not difference of 2 squares, but it is sum of 2 cubes. So I can make that 1 plus x cubed, because x cubed to the 3rd power is x to the 9th. This is going to be 1 minus x cubed plus x to the 6th power. That expression, that second expression, that trinomial, can't be factored, but the first one can. I do the same thing again with these cubes. And we get our final answer. Notice this sum and difference of cubes thing is not going away, so keep practicing it. The last question, if you prove this is an identity, you want to prove the left-hand side is the same as the right-hand side. So whenever you square something, you're just multiplying it by itself, x, y, x, y. So I have x squared, x, y, y squared. So I have x squared plus 2xy plus y squared minus, now if you're really smart, you know, this and this becoming minuses, just make this negative 2xy So you don't even have to do this over. You already did the multiplication. So you have x squared minus 2xy plus y squared equals 4xy. If you do your subtraction, the x's are going to cancel, the y squareds are going to cancel, double negative becomes a plus, so you have 4xy equals 4xy. Hopefully this video helped. If you're struggling with factoring, I am after school next week. All right, so come and see me. We will practice it. We'll go over it. I hate to say it, but it just never goes away. We will be factoring all year. So please make sure you start out on the right foot here and you're watching these videos to make sure that you do your homework right. Good luck and have a great weekend.